Hey guys, welcome to the Level 1 Tables, Equations and Graphs paper for 2018. So the way this video is going to work is that I'm going to go through each one of the questions, tell you guys what you need to do for Achieve Merit and Excellence. One thing I'd recommend is pausing the video at the start of each question and trying out the question by yourself just to see how far you go with the question. Just with a note about this particular exam paper is that there was a lot of changes that were actually done last year. So just bear with me as I go through this paper. Okay, let's get started. Okay, so the first question here, we've got to find the equation of the graph below. And so I'm going to show you guys a couple of methods of doing this. First method is without a graphics calculator, and the second method is with a graphics calculator. So without a graphics calculator, what you have is, we know there's a straight line, so we can actually see that this is equal to y equals mx plus c. Now c is the y-intercept, so in this case it's going to be 6, and then m is the gradient, which is the slope. So to figure out what the slope is, we've got rise over run. So I'm going to take 2 points. So I'm basically going to choose this point right here and this point right here and see what the rise and the run is. So if you look at it, it's actually going 6 down and it's going to the right 8. So we can actually say that the gradient is equal to -6 because it's going down, divided by +8 because it's going to the right. So this can be simplified as -0.75. So then our equation is going to be y equals to -0.75x plus 6. So that basically gets you an achieved. Now to do this in the graphics calculator, you need 2 points. So the first point I'm going to choose is 0.6, and the second point I'm going to choose is 8.0. So what you do is in your graphics calculator, let me see if that works. Yep. So go into menu and then go into stat and put in your 2 coordinates. So you've got 0 and 6, and then you've got 8 and 0. Okay, then you click on calc. No, not calc, sorry. Exit. We're going to go to graph, which is F1, and then graph 1, calc, and then you got this X there, which is a straight line. You click on that, and it tells you what the A value is, which is -0.75, which is the same thing as the gradient. And then B is the y-intercept, which is 6. So it basically has that y equals mx plus c format right here. Okay, so this question here is worth an achieved. All right, let's go to the next question. Okay, the second question here we've got is James takes 40 minutes to jog 5Ks, and they're asking for the average speed. So if they're looking for the average speed, then you've basically got 5 kilometers divided by 40 minutes. So which means, putting this in the calculator, what we're going to get is 0.125. So that's basically 0.125 kilometers per minute. And then that ends up being achieved. Okay, so that's kind of like the easy part of this question. Let's go to the second part of the question. So this is our second part of the question. So pause this video and have a read through it, folks. And then we're going to try and kind of figure out a way how to actually solve this. Okay, so to kind of get started on this question, like there's a couple of things that we need to go back to from the previous part of this question, which is that James actually takes 40 minutes to jog the 5Ks from his home to school. So to go to this question, we've got, I'm just going to kind of roughly draw a sketch here just to show you the idea first, and then I'm going to show you guys how to draw it separately. So we know the school from where James starts, it's 5 kilometers. All right, so what I'm going to do is I'm going to put down distance and I'm going to put down time. So let's say this is at 5 kilometers and then this is at 40 minutes. All right, so James, I'm going to plot him in a red color. So this is James's line right now. Okay, that's from the previous question. So it takes him, he runs 5Ks in 40 minutes, and that's what the what do you call it, the school is away from. Now Emma actually lives further away from the school than James. I'm going to go with Emma with a green line. So I'm going to go with this color here. they leave their homes at the same time. So if Emma is living away from James's house, so she's probably starting somewhere down there. We don't know where it is, but somewhere down there. She rides a bike to school and James jogs to school. So James is still running, but they meet 20 minutes after they leave their homes. So that means, so 40 is here, 20 is somewhere here, and at this point, Emma is actually meeting halfway. So that means we also know the distance, because it's 20 minutes and James is running at that average speed, that's going to be 2.5 Ks. All right, after they meet, both James and Emma change their traveling speeds. So because they're changing their traveling speeds, I kind of don't need to worry about this part here, because now they're together. James begins running and Emma rides a bike at 3/4 of the speed she'd been traveling before they met. So whatever this light green line is, she's only traveling now 3/4 of the speed. So that means, and they arrive at school 30 minutes before after they left their homes. So normally James is actually running, and so this was normal situation, right? So let me just show that again. So normally it would have taken them 40 minutes, but because they changed their speed, it's going to take them 30 minutes. Let me see if I can choose a different color. That's not a nice color. Let's go with, I'm trying to find see if this one works. So that's that at 30 minutes they actually reach the school now. Okay, so now we've been asked to represent Emma and James's journey from their homes in a graph. Now we've done a rough sketch here. So what we're going to do is kind of draw it up a bit. And I think we've been given a graph. So what I'm going to do is I'm going to kind of take this sketch, see if I can do that. Let's go to the graph. Okay, so I just need to draw it a bit more accurate. Now it's going to be very tricky for me to draw on tablet, guys, but when you guys draw it, please make sure you're actually using a what do you call it? Using a ruler for this particular part, all right? So I'm just going to kind of roughly sketch things out. So I'm going to have my x-axis. Oh, they've actually done it quite nicely. They 1, 2, 3, 4, 5. Because I know that I'm only working for 5 kilometers and the boxes are put in nicely, I'm going to start here. And I'm going to kind of call this the time. And that right there is going to be distance. So 1, 2, 3, 4, and 5. And then here I'm going to have 10, 20, 30, and 40 minutes. Okay, so James is going to meet at 20 minutes and 2.25. Sorry, James is going to meet at 20 minutes and 2.5. That's where they're meeting, not 2.25. So we're going to connect that line up here to 2.5 for James. Again, for you guys, please make sure that you actually use a ruler for this. And then we also know when Emma and James join together, they take 30 minutes to actually reach 5Ks. So, whoa, it's going to look like this. Okay. I know it's not the best diagram, guys, but for you guys, please make sure that you actually use a ruler for this. Now, we also need to actually figure out what was Emma's speed before meeting James. All right. So we actually look at what her speed currently is. I mean, when they're running together, when they're going together, they meet at 20 minutes and 2.5 Ks, and then they finish off the journey at 30 minutes and 5 kilometers. So if I look at rise over run, I've got 5 minus 2.5, which is 2.5. 30 minus 20 is 10, which equals to 0.25. So 0.25 is what they are going together. So if I look at this green part of the line, that's 0.25 kilometer per minute. So I need to figure out what Emma was doing before that. Remember, the question actually said she travels right here. They began running and Emma rides a bike at 3/4 of the speed she had been traveling before they met. Okay, so if that's the case, we now know that 0.75 times whatever Emma's speed before they met is now equal to 0.25. So we can actually see Emma's speed before they met was 0.25 divided by 0.75, which is 1/3. Okay, now the reason why I'm putting this as 1/3 is because it's actually a lot easier to put it as a graph. And so that's what I'm going to do, Emma's speed before they met. So it was 1/3. So if you look at it like over 20 minutes, so if you actually look at what 1/3 is, 1/3 is actually 0.66 kilometers per hour, sorry, per minute. So if it's 0.66 per minute over 20 minutes, what you can say is, okay, I know I'm kind of fluffing about with this. I do apologize about it. Just trying to figure out how to explain it in a way that actually makes sense. So let's see. We know that she's traveling at 0.66 kilometers per minute. Or we can actually say that she's traveling 1 kilometer for every 3 minutes. Okay? So what that means is that you can actually track back. So if it's 1 kilometer for every 3 minutes, then she's actually gone 2 kilometers over 6 minutes, which means 2.5 kilometers is going to take her 7.5 minutes. Okay, now the reason why I'm looking at 2.5 is I'm trying to figure out how long, because 2.5 is right here. So this is the 2.5 kilometers. And I'm trying to figure out how much time before she actually used. So before means 7.5 minutes. So 20 minus 7.5 is 12.5. So that's where that 7.5 minutes comes in. So when I think about drawing this as a line, it's going to end up looking like it's going to go through that point there. And that's really important that you actually get through that. Sorry for messing about this, guys, but it's just, as I said to you earlier, this exam paper is just annoying. That's all I'm going to say. So grades wise, if you plot James's journey correct, you're looking at a achieved. All of James's journey represented on a graph correctly is achieved, or all 3 speeds calculated and stated gets you a merit actually. So we're looking about Emma's speed before and after, and also James's speed. And then if you actually draw the graphs correctly, all 3 graphs correctly, you get an excellence. Painful question, but let's go to the next one. Okay, guys, so for the part 3 here, we've got to actually work out what the equations for all of these graphs are. So first, I'm going to actually get James's equation. So James's equation is fairly easy because in the sense where we can say y is equal to 0.125 because that was the speed multiplied by x. Now we also know a couple of other things. Is we know that Emma, because we did for Emma's one before she met, we didn't actually get what the c value is, but we do know this point here is 12.50, and then this point here is 22.5. So with that in mind, we can actually figure out what Emma's equation before she met was. So that's the light green equation. So Emma's equation, we know that her gradient is actually equal to 1/3. All right, and that's all we really need because we know that y equals to mx plus c, and we also know that she meets at 20 minutes and 2.5 kilometers. So we just substitute that in here. So we're going to get 2.5 equals 1/3 times 20 plus c. So we've got 2.5 is equal to 20 over 3 plus c, and c is equal to 2.5 minus 20 over 3. I'm just going to put that in the calculator real quickly, guys. So 2.5 minus 20 over 3, which is this ugly number, If I put it in a fraction, it's negative 25 over 6. So I can say C is equal to negative 25 over 6. So the equation for Emma is 1/3 x minus 25 over 6. Now, this is before they meet, so I'm just going to put that here as Emma before they met. And then I'm going to put down after they met. Now, after they met, the gradient was 0.75 because that's what we actually figured out from earlier. And once again, we got the point. We've got the starting point for them, which is 20 and 2.5. So we're going to put that into the equation. So y equals mx plus c. And we've got 2.5 is equal to 0.75 times 20 plus c. So 2.5. Something ain't right here. I think I realized where my mistake is. Their gradient was actually 0.25. Yeah, sorry. The gradient was actually 0.25, not 0.75, which means that there is going to be 0.25. So 0.25 times 20 is 5 plus c, and then you've got 2.5 minus 5 equals c. Therefore, c is equal to negative 2.5. So after they meet, the equation is 0.25x minus 2.5. So grades wise, all equations done correctly gets you an excellence. 2 equations gets you a merit. And I think 1 equation gets you an achieved. All right, so that's basically it for the third question. Let's go to the fourth one here. So for the fourth question, they've actually asked, describe Emma's journeys to school, including their speeds and how far Emma's home is from the school. So what I'm going to do is first I'm going to convert their speeds into kilometers per hour. So let me just see if this pops up. Here we go. So James actually was doing 0.125 kilometers per minute. So if I multiply that by 60, I actually get 7.5. So this is the first part of the story that I'm saying. So James, I need to write it. James traveled at 7.5 kilometers per hour before he met Emma. And then you can say something like Emma traveled double L at, I think Emma was traveling at what was her speed before they met? It was 1/3. So then I'm going to go 1/3 times 60, which equals to 20 kilometers per hour. So traveled 20 kilometers per hour before she met James. Then I think they traveled at 0.75 together, was it? Or 0.25. Yeah, I think it was 0.25 was when they traveled together. So 0.25 times 60 gives us 15 kilometers per hour. So we can say together they traveled at 15 kilometers per hour after they met to the school. What else can we write? We can also say that Emma and James met at 20 minutes, 2.5 kilometers away from school. And the last one is how far Emma is actually living. Now, if you remember the equation for Emma's, you've got, I'm talking about this value here, minus 25 over 6. So if you look at it in a graph format, all right, so the school is right here at 5 kilometers, and then this is where Emma's equation kind of meets at negative 25 over 6. So the distance between Emma and the school is this red line here. So then what we got to do is we got to go 5 plus It's not negative 25 over 6 because that's in the opposite direction, so I'm just going to put that as 25 over 6, which actually gives us this particular value, which is 9.167 kilometers. So we can actually say that as a statement, that Emma lives 9.167 kilometers away from school. So this question here, as annoying as it is, you need 3 valid statements made. So I've given about 1, 2, 3, 4, 5 statements here, but you need 3 of them to get an excellence, 2 of them to get a merit, and 1 of them to get an achieved. Okay, let's go to the next question. All right, guys, so when you are asked to draw the graph of this particular exponential, what I generally tend to do is create a little table, x and y. So when x equals to 0, I'm looking for, I'm going to do this extra bit of the table here. So I'm looking for 2 to the power of 0 plus 1, so that's 2 to the power of 1, which is 2. When x equals to 1, this is 2 to the power of 1 plus 1, so it's going to be 4. When x equals to 2, you're going to get 2 plus 1, which is 3. 2 to the power of 3 is 8. Okay, so now we're asked to draw a graph of it on the grid below. So I'm going to just roughly sketch it at the moment. But for you guys, for your sake, I'm hoping that you guys are drawing this a bit more accurately. So at 0, it's going to be at 2. At 1, it's going to be at 4. At 2, it's going to be at 8. Okay. And of course, if I want to go back a little bit in this table, just to give me a bit of a heads up, is that I can actually put minus 1. And I'm going to get 2 to the power of minus 1 plus 1 is 0. So 2 to the power of 0 is 1. So that means that green point, when x equals negative 1, y is equal to 1. And right there, you should be able to see the shape that you can actually draw. All right, a nice smooth curve. And of course, it's not actually touching the x-axis. Okay, so for achieved, you need to get 3 points correct. So that's why I've actually used this table here, because that actually helps me get an achieved. And then also, even if you don't draw the graph, but you have 3 points correctly found in a table, you can get achieved for this as well. And then finally, you get merit for doing the right graph, sorry, not grade. Okay, so let's go to the second part of this question. So the second part of the question, it says, if the graph was moved 3 units to the right and 4 units up, give the equation of this translated graph. So basically what it's saying is it's going 3 units to the right and then 4 units up. Okay, so the original equation of this graph was y is equal to 2 to the power of x plus 1. So this was the original graph. So basically, when you do transformations like this, when it goes up by 4, then we replace it with plus 4. All right, and then the next part is when you're going right by 3 units, you just got to replace wherever x is, wherever you see x, replace it with, like add another minus 3 in it. So this equation would then end up looking like this: 2x minus 3 plus 1 plus 4. So this simplifies to y is equal to 2 to the power of x minus 3 plus 1 is minus 2, and then plus 4. So for this question here, getting the plus 4 or minus 3 minus 2 correct will get you an achieved. By getting the final equation will get you a merit. All right, let's go to the next lovely question. And here we go. So take a moment to pause this video and read the question, guys, and then we'll go through it very shortly. Okay, so what we actually have in this question is we've got a lovely exponential equation, and our first question here is asking us to find out how many more students visited for the first time on the 4th day than on the 3rd day. So what we actually got to work out is the number of kids actually reporting on the 3rd day first, and then the 4th day. Now, it also says that n here is the number of days. So my first number is going to be y is equal to 2 to the power of 3 plus 3, which means I'm going to get 8 plus 3, which equals to 11. That's for the 3rd day. And then for the 4th day, I'm going to get y equals 2 to the power of 4 plus 3. So 2 to the power of 4 is 16, plus 3 is 19. And then so I got 19 take away 11 equals 8. So I can actually say number of additional students is equal to 8. Okay, and this question here, fairly straightforward question to get and achieved. Yeah, so that's what it is. Okay, second part of the question. It says, give the equation that represents the number of students who are recorded as going to the nurse on any day when n is greater than 1. So let's have a look how to do this. So guys, the clue for this is in the previous kind of question, all right? Because on the previous question, we actually had a look at number of additional names that came on the 4th day as actually 8. So what I'm going to do is I'm going to create a little table here just so that, see if we can actually kind of make sense with this, all right? So we got 2, 2nd day, 3rd day, 4th day. Now for the 4th day, we just actually worked out it to be, the difference to be 8. And the way we worked it out was we actually went 2 to the power of 4 plus 3 minus 2 to the power of 3 plus 3, all right? So if you look at the third one, what we're going to get is 2 to the power of 3 plus 3 minus 2 squared plus 3. So that's going to be 8, 11, take away, because I'm talking about 2 cubed is 8, 8 plus 3 is 11. Just gonna keep doing this here. 11 minus 4 plus 3 is 7, so that's going to be 4. And then I keep repeating it. So 2 squared plus 3 minus 2 to the power of 1 plus 3. So that's going to be 7, take away 5. So that's going to be 2. And if I was to keep carrying on for the 5th one, then what I'm going to get is 2 to the power of 5 plus 3 minus 2 to the power of 4 plus 3. So 2 to the power of 5 is 32, so that's 35. Take away 2 to the power of 4 is 16. 16 take plus 3 is 19. 35 minus 19 is 16. Okay, and you can kind of see a pattern that's actually forming here. So what happens if this ends up being n? So all it is that, and I guess this is where you really need to be good with your exponent numbers, like recognizing patterns. In this pattern, what I can see is that normally, I know that, let me just show you guys on this side. If I have 2 to the power of 5, then I know 2 to the power of 5 is equal to 32. 2 to the power of 4 is equal to 16. 2 to the power of 3 is 8. 2 squared is 4. So this is if it's 2 to the power of x, right? But the problem is all these numbers have actually shifted down 1. So that means the equation for n, I could actually write it as 2 to the power of n minus 1. Because think about it, if I actually put 5 into this n here, 5 minus 1 is 4, 2 to the power of 4 is 16, and that's how I get that 16. So that's actually one way of getting this equation. The second is actually doing it by algebraically. So algebraically, if you look at it like this, so whatever the previous day's numbers, you can say it'll be 2 to the power of n minus 1 plus 3. And then on any day, on the day after that, so the day following that previous day, you're going to have 2n plus 3, which is what we have. So we're now looking for a difference between the two of them. So that means for any day, you're going to get 2n plus 3 minus 2n minus 1. Sorry, I just screwed that up. 2n plus 3 minus, and I'm going to put this in bracket, 2n minus 1 plus 3. So if I expand this out, I'm going to get 2 to the power of n plus 3 minus 2 to the power of n minus 1, and then minus times positive 3 is minus 3. So my 2 3's, they kind of disappear, and I'm left over with 2n minus 2 to the power of n minus 1. Now I need to write this equation in the simplest form, because that's what the question is actually telling me. So I got a little bit more work to do in this, but what I'm going to do is I need to go back to using my algebra for this. So I'm going to have this as 2n minus 2 to the power of n divided by 2 to the power of 1. Now notice how I've actually done 2 to the power of 1, because if you remember your algebraic rules, If you have a to the power of m over a to the power of n, then this would be a to the power of m minus n. Now, 2 to the power of 1, I'm just going to leave it as 2, just to make things easy. And then I've got 2n minus 2n over 2. So what's another way is I can actually make the 2n on the left-hand side to be having the same denominator as the right-hand side. So I'm going to multiply the numerator by 2 and the denominator by 2. So what I end up getting is 2 times 2n minus 2n, and the whole thing is over 2. So 2 times 2n minus 2n is just going to be 1 2n over 2. And because 2 is the same thing as saying 2 to the power of 1, the final answer ends up being 2 to the power of n minus 1. So what you'll notice is this is the same answer that we actually got in the table as well. Okay, that's basically how you do this question, guys. Yes, you predicted it correct. It is an excellence question. Now you can get this equation from a table or a graph, so either one is fine. So that's what an excellence is, to get the final equation. Merit, expression given by subtracting n minus 1 term from the nth term. So I would probably say somewhere here is probably your merit. And achieved is giving that differences in a table or a graph format. Yeah, or expression given for 2n. So this could also be an achieved right there. Okay, I do apologize. It is not a fun question to do, but yeah, that's what we're actually looking at. Okay, let's go to the next question. This paper is getting miserable and more miserable as I read through it. What do we have here? Here we go. Okay, I hope you guys had a chance to actually read through the question. I did forget to mention that pause the video to read through the question. But basically, what's happening here is I'm going to give you guys a rough diagram of what this thing looks like. So we got that exponential function, right? 2n plus 3. So that basically is going to go like this, and it's going to increase slowly all the way up to 67. But when it reaches 67, then the numbers start to decrease, and it's going to look in the shape of a quadratic, which is actually here. So that's the quadratic. So after 67, it's going to drop into a quadratic. So we're trying to figure out how long it actually takes for that to actually happen. So the first thing we got to try and figure out is what is this point here, and then this point, and then you got to add up both of these to actually tell me the total number of days. So the first step is we know the equation is, we want to find out when does that exponential equation equal to 67. So I know that exponential equation is 2n plus 3, and that equals 67. So rearranging this, I've got 67 take away 3 equals 2 to the power of n, and I've got 64 equals 2 to the power of n, and I can straight away know that n is equal to 6 because 2 to the power of 6 is 64. So that first point is going to be 6 days. Okay, so that's when you have 67 recorded on the 6th day. So this basically gets you a grade of achieved to start with. Yep, that's all good. And then now we're going to try and figure out this quadratic here. Now this quadratic here, just going to show it in a different color. Maybe not that color. Let's go with black. No, not black. Let's go with red. So this quadratic is going to look like this, and we want to try and figure out when is this quadratic going to equal to 0. So we literally just need to do, what is it? So 0 equals minus x minus 5 times x plus 3 equals, not equals, plus 9. So two ways you can actually do this. One is you can rearrange and find out what x is, or you can actually chuck it straight in the graphics calculator as well. I'm going to do it the long-winded way, which is, should I do it? Yeah, let's just do it the long-winded way. So I'm going to take the negative x minus 5 and x plus 3 to the other side. So that means that x minus 5 stays as it is, x plus 3 stays as it is, but that minus right here, this minus is going to disappear, and you're left with 9. So expand the quadratic. I've got x squared plus 3x minus 5x minus 15 equals to 9. So I've got x squared minus 2x minus 15. 9 comes over to this side to be minus 9. That's equal to 0. So then simplifying this, I've got x squared minus 2x minus 24 equals to 0. Factorizing it, I'm looking for two numbers that multiply to negative 24 and add to negative 2. It's going to be minus 6 and plus 4. So therefore, I can say that x is equal to 6 or minus 4. So this little parabola that I have here, it's maybe not looking like this, but it probably could look something like that, and then it ends up back there. So that's at minus 4, and that's at 6. So what I've got is I'm going to be honest, guys, I'm actually stumped in this particular question because unless I've read something wrong somewhere, the final answer, it actually says it's 12 days. So I'm trying to figure out how that works out. I guess their particular reasoning is that it actually takes 6 days to reach 67 patients, and then it takes another 6 days to reach 0. So altogether, it's 12 days. To me, personally, I'm finding this question a bit hard to understand. And I do remember people having a discussion about this particular question online at the end of last year. I just need to go back and have a look whether it was this question, because there were some questions that were quite nasty, and I'm probably thinking this is one of those questions. So grades wise, 12 days gets you an excellence. Additional day of 6, so using the quadratic to actually solve it gets you a merit. Has a tabular graph to find the additional 6. Right, I guess, okay, so I guess the reason why maybe my graph here was not the best representation of it, but what they've actually done it is like almost like two separate graphs. So the way they've done it is, I think that's why the confusion is happening here. So their first graph was like reaching to 67, and then their second graph was like from 67, it actually kind of come down to 0. So that's where that extra 6 days comes in. So my kind of drawing, the initial drawing here, is probably not the right way of looking at it to actually work out that extra 12 days. Cool. So I do apologize for the craziness, but welcome to Tables, Equations, and Graphs. All right, let's go to question 3, guys. And hopefully we get some nicer questions. There we go. Sorry guys, had a technical glitch there, but basically for this question here, if you want to do this, is you can do this by the graphics calculator, or you can actually do it manually as well. I'm going to show you guys how to do it manually real quickly. So that's -1 there, and that's 5. So those are my two intercepts. So I'm going to write them down as x minus 5, x plus 1. Now every equation with a quadratic is going to have an a value, and I just need to figure out what that a value is. To figure it out, I'm going to use a point, and I'm going to pick a pretty nice point, which is the vertex right there, which is 2, -9. And so when I substitute 2, -9, I get a, 2 minus 5, 2 plus 1, and I've got -9 equals a, -3 times 3, -9 equals a times -9, which means a is equal to 1. So therefore, the equation is x minus 5 and x plus 1. If you're using the graphics calculator, what you could do, if I can find my calculator, which is not popping up, there it is. Go into menu, go into stat. You need to put in 3 points. So the first point is -1 and 0. Then your second point is 5 and 0. And then your third point is 2 and -9. So click on graph, graph 1, calc, and then go into x squared, which is f4. So there's your ABC values, 1, -4, -5. So you write that down as an equation. So y is equal to, because you know how this has this ax squared plus bx plus c format. If you forget that formula, it's actually pointed in the calculator here at the bottom. So write that equation down, but then replace the a, b, c with these values here. So you're going to get y is equal to 1x squared minus 4x minus 5. All right, so that gets you a nice achieved. And then let's go to the next question. Lovely. I believe I saw this same question, very similar to this question in the MCAT for the year. So original, using your same questions again. So what have we got here? We just got to try and got two possible designs. And she wants, just pause the video, guys, and have a read through the question and see what you can actually do with it. So yeah, so the first question here, it's actually asking us, well, let's actually go to the question. It's asking us to investigate a relationship between area of the red circle and its radius as the radius increases. Okay, so I'm kind of going to work on the table here just to see if we can actually fit the area here. So just to read a few things and kind of work through it here. So we're trying to work out a relationship between the red circle's area and its radius. Okay, so I'm going to go right here and I'm going to put down first what the diameter is, the radius, and then the area. So first up, the radius for it is it has to be at least 1 centimeter for either circle. So that means you can have a radius of 1. If I have a radius of 1, then the diameter for the red circle is going to be 2. And she also uses pi as 3, just to make things a little bit more complicated, which means area of that first circle is going to be pi r squared, which is, so 3 times 1 squared. So that's going to be 3. Now look at the radius when it's 2, for example. So if the radius is 2, then the diameter is equal to 4. So she's going to get 3 times 2 squared, which equals 12. And then if radius is 3, then the diameter is 6. So 3 times 3 squared equals 27 is the area. And then when the radius is 4, the diameter is 8. So 3 times 4 squared is 48. And I guess you can't actually go a radius of 5. The reason you can't go radius for 5 is the distance is only 10 centimeters. All right, and that means if you put red circle as radius of 5, then the diameter will become 10. And what will happen to the red circle is that, it looks like this. And they actually tell you that each radius has to be at least 1 centimeter, which means the maximum it can actually go up to is actually only 4. It can't actually go to 5. So yeah, so that's basically what you need to do for this one. Correct table or graph from x equals 1 to 4, it gets you an excellence. And also the radius must be from 1 to 4. I'm trying to understand the marking schedule, guys, but it seems like unidentified. So this is just one part of the question. So correct table from that. So this is going to get you up to a merit. And I think you can actually do part 2 of the question. You've got to do 2 parts of this question to actually get an excellence. So this is the first part to get a merit. Achieved, if you calculate like 2 areas correctly, you can get an achieved. So let's go to that second part of the question and see what else is being asked. So it says, describe the major features of the graphs that represent the relationship between the area of red circle, blah, blah, blah. So what we then have is, I'm actually going to go back and get that table. So the table there was like, if you remember, we had radius and then we had area. So radius was 1, 2, 3, 4, and then the area was 3, 12, 27, and 48. So we've got to try and figure out what this graph is. Now, I know it's a quadratic because, we're kind of working with area, and majority of the time it ends up being a quadratic when you're dealing with area. So I'm going to put this numbers down. So I've got 1, 2, 3, 4. And then here, I'm going to put down 3, 12, 27, and 48. And I'm going to go to graph, calc, x squared. And what you see is y equals to 3x squared, because there's no bx plus c or anything like that. So this is just the equation of the graph is y equals to 3x squared. So it says describe major features. The first feature that I'll actually say that it's got a minimum area of 3 when radius is 1, because it can't actually have a radius below 1, and it has a maximum area of 48 when radius is 4, because you can't really have a radius higher than 4. And then so you basically say, as radius increases, area increases as well. So correct graph, correct, consistent with table of values. So this one you can actually do it as a graph or an equation. I've just done it as a graph here, guys, because I've done it as an equation because you can actually do it. So to get an excellence for this question, you needed the merit from that first part, and also mention 2 features, which also gives you a merit, because there's like a lot of ors in the answer schedule. So you need to get 2 features and that table to get an excellence. Whew, hopefully that made sense. Let's go to number 3. State the equation that graphs represents the total area of red and blue circle. Oh, fantastic. So the good thing is we've actually got the first part of this done already, because we've got radius, which is going to be 1, 2, 3, and 4. We've got area of the red circle, which is 3, 12, 27, and 48. So this is the radius for red circle. So what you need to do is the opposite of it. So the radius of the blue circle, if the radius of the red circle is 1, then the blue is 4. If it's 2, it's 3. If it's 3, it's 2 and 1. So I'm noticing that you guys can actually see that when you add their 2 radiuses up together, you will always have 5. And also, we've actually worked out what the area of the blue is as well, because it follows the same principle as the red one. So when the area for the when the radius is 4, the area is 48. So we're just going to reverse the numbers like this. And what we're going to do is we're looking for total. So the total area is going to be 48 plus 3, which is 51. So I'm actually doing this now for totals. Then you got 27 and 12, which is 39, 39, and 51. So in terms of grades, correct one area, sum correctly. So one of these things correct gets you an achieved. The full table gets you a merit, but you need an equation of the graph. Okay, so that means if you want an equation for the graph, I'm actually going to compare these 2 things here. So I'm going to compare the radius of the red circle with the total area, which means I need to go back to my graphics calculator. And it's kind of nice that I only need to change the y value. So I'm going to put that as 51, 39, 39, and 51. Go into graph, calc, x squared, and then you can see my A, B, C values. So 6, negative 30, and 75. So I write the equation then. So total area, where with R being radius of red circle, I can say that area is equal to 6R squared minus 30R plus 75. So if you have a look at those ABC values, you've got 6, negative 30, and 75, and I've just written that down as is. Okay, so you need to do that to get that final grade of excellence. All right, so let's go to the last part of this question. Okay, so what they now have is they've got that last part of this question where they want the general equation for the total area, total of the areas of the red and blue circles where the sum of the radius is n centimeters. I'm going to go back to that first table that we actually had, right? But rather than that, I'm going to look at it like this. So area of the 2 circles, is, I've got blue circle plus the red circle. Okay, and I think this is similar to what we did in the MCAT as well. So what we do know is the radius themselves let me just change some of these colors. So so what we have is the radius of the blue circle plus the radius of the red circle equals not to 5, but to n in this case. Okay, so what I'm saying is that radius of blue plus radius of red one equals to n. So that means I can actually write them all in one kind of thing. So what I'm going to do is I'm just going to rewrite this with the colors itself like this. So blue circle's radius plus the red circle's radius equals to n. So when I actually go into this area function and I've got blue circle, so that's going to be pi, well not pi r squared because she's actually using 3. So 3 times r squared plus the red ones, which is 3 times r squared. All right, but here's the thing though, the red r could be written as n minus the blue r. So what I'm going to do is I'm actually going to replace the red r here with n minus blue r. I hope it kind of makes sense what I've done here. So what ends up happening is you've actually got 3 times r squared plus 3 times the n minus r squared. Okay, so once you get that, it's just a matter of expanding things. So you got 3r squared plus 3 times n minus r times n minus r. 3r squared plus 3 times n squared minus nr plus r squared. So 3r squared plus 3n squared minus 3nr minus 3nr plus 3r squared. So this simplifies to 6r squared minus 6nr plus 3n squared. And that's your generalized formula there. So that ends up being an excellence relationship stated for areas of both circles in terms of n and r. So that's a merit stated for one circle in terms of n and r. Jeez. So I guess that could be one of these things here. Kind of writing it like that. Okay. Is that all it is? Yes, that is all that there is to this god-awful paper. So yeah, guys, that was that's basically the level 1 tables, equations, graph paper. As you can see, I did not enjoy making this video at all. I'll be brutally honest. This video has taken me just over 1.5 hours. Normally I make a video in about 50 minutes. I think 50 to 1 hour is what I spend most of the time making videos, because questions are fairly straightforward and easy, and you can just kind of get the job done. But I will tell you guys one thing. Tables, equations, and graphs has just become one of the most messiest papers at level 1 that I've ever seen. So don't get disheartened. That's what I'm trying to tell you guys here. And I say the same thing with the MCAT as well. I've actually found people can actually get through level 2 algebra and level 2 calculus with far more ease compared to tables, equations, and graphs. It's just become a nasty, nasty paper. I'm not sure why they do it, but that's how it is. So in saying that, don't leave any questions empty, guys. Just make sure you attempt every question. Just doing little things, you might pick up a grade here or there, so don't leave anything empty. This is one of these unique papers where they've actually said they accept answers as tables, equations, or graphs. So if you're not good with graphs, you're not good with equations, just do a table. That'll still work out as well. Okay, so guys, that's basically it from me. As always, if you have any questions or comments, put in the comment section below. Of course, don't forget to like this video and share this video with your peers. Also, don't forget to subscribe so you can keep up to date with any kind of live tutorials that are happening, and also check the links above for more help. That's it from me. Thank you for watching, and good luck for your exams.